The universe we see today, alive with light, stars, and galaxies, is merely the opening chapter of a much longer story. For the last 13 billion years, we've lived in the stellar era, the age of stars. But even this brilliant phase will one day end. In the Triangulum galaxy, the cycle of stellar birth and death is already well underway. The most massive stars, those luminous blue giants burning with the intensity of millions of suns, are the first to die. They live fast, burn bright, and vanish young, lasting only a few million years. Some explode in spectacular supernovae, enriching the galaxy with heavy elements. Others collapse directly into black holes, vanishing from view, but leaving behind immense gravitational footprints. These deaths seed the interstellar medium with carbon, oxygen, iron, the raw materials for planets, life, and future stars. Meanwhile, medium-mass stars, like our Sun, live more balanced lives. They burn steadily for billions of years, fusing hydrogen into helium in their cores. When their fuel runs out, they swell into red giants, engulfing nearby planets. Eventually, they shed their outer layers, forming glowing planetary nebulae, leaving behind a small, dense white dwarf core. This white dwarf, no longer undergoing fusion, slowly radiates stored thermal energy, cooling over tens of billions of years, first glowing white-hot, then red, then fading to black dwarfs, cold, dead embers adrift in space. But the most enduring stars of all? Red dwarfs. These low-mass stars, with less than half the mass of the Sun, are cosmic misers, burning their fuel so slowly they can shine for trillions of years. None have died yet. The universe simply isn't old enough. But one day, even these long-lived flames will flicker out. Triangulum is filled with such stars, quiet, stable, and faint. In the far future, when the giants and medium stars are long gone, these red dwarfs will dominate the night sky. They will be the last beacons of visible light. But not forever. As time passes, the galaxy will grow darker. Star formation will cease as gas is exhausted. Existing stars will die out. Triangulum, like all galaxies, will enter a degenerate era, an age defined not by light, but by remnants. White dwarfs, neutron stars, black holes, and cold brown dwarfs will populate a dimming cosmos, a galaxy of ghosts. Occasionally, chance gravitational encounters may spark rare events. A white dwarf colliding with another, reigniting briefly. Or two black holes spiraling inward and merging, sending out a burst of gravitational waves. But such events will become rarer and rarer. Energy will disperse. Motion will slow. Stars will no longer shine. In time, black dwarfs may even undergo theoretical processes like proton decay, dissolving into radiation over unimaginable timeframes. Eventually, only black holes will remain. Triangulum's massive stellar black holes, and perhaps a central supermassive black hole, will continue to warp space around them. But even they are not eternal. Through Hawking radiation, black holes slowly lose mass. Over trillions of years, they too will evaporate. When the last black hole disappears, the universe will enter its final stage, the dark era. No stars, no galaxies, no light. Just a thin mist of particles spread across a frozen cosmos. This is the long twilight of existence. Yet even this future is written in the stars we see today. In Triangulum, the dance of birth and death continues. But it is a countdown. Every new star formed is one step closer to the end of starlight. We live in a brief golden age, a flickering moment in which the universe still glows. Billions of years from now, future civilizations may look up and see only darkness. No Triangulum, no Milky Way, no stars, only memory or legend. That's why this time is precious. the universe is young and alive. And the Triangulum galaxy, spinning, shining, birthing stars, is a reminder of all that still burns before the long cold begins. We are stardust with a window into eternity, and that window is still open.